Daily work unit 4-4. The first picture gives us a rectangle. We're going to use the properties to answer all the questions, or basically to fill in the picture, because the question asks about every little piece. We don't have to. We don't want to have to rethink that whole picture 9 times. So we're going to just do the picture, and then all the answers will be there. You see. We know that both pairs of opposite sides are parallel. If opposite sides are parallel, then we have alternate interior angles are equal, corresponding angles are equal, same side interior angles are supplementary, all those things. So if this little angle right here is 27 degrees, then this angle is going to be 27 degrees because alternate interior angles are equal. If it's a rectangle, then the diagonals are equal and bisect each other. So if this is 7 and this is 7 and this is 7 and this is 7, in a rectangle, all four little diagonal pieces are the same because the diagonals are equal and bisect each other. That being the case, we have four isosceles triangles. If two sides of a triangle are equal, then the angles opposite those equal sides are equal. So those are both 27 and those are both 27. We know that the sum of the angles of a triangle is 180 degrees. So if we add up those two 27s, we'll get 54. If you subtract that from 180, you'll get 126. And so this obtuse angle right here is 126. And the one across from it, which is vertical to it, is 126. An exterior angle is equal to the sum of its two remotes, and so this angle is 54 because it's the sum of the two 27s. You could also say the sum of the angles of a triangle is 180, and you could solve for it that way. Or you could say a linear pair is 180, solve for it that way. We know that if it's a rectangle, then the whole big angle here is 90, and 90 minus 27 would leave 63 degrees for this one and 63 degrees for this one. And I know that that's a little bit hard to see. Also, opposite sides are equal. And so IQ, which is from here to here, is one of those four diagonal pieces. And in a rectangle, the diagonals are equal and bisect each other. So that's 7. ZP, one whole diagonal, is twice that, 14. QP, half of a diagonal, 7. ZI, this side over here, is 6. And then we get the angle measures. Now, that got kind of cluttered, I know. Let me kind of erase and see if we can do a little bit better job. What we ended up with is all four of these little angles, if I can get it to go exactly where I want it to, are 27. See that? So we got all four of those little angles are 27 degrees. We ended up with these two angles in here being 54 degrees, those vertical ones. We ended up with these two angles right here being 126 degrees, 126. So we've got angle ZPI. ZPI was one of those 27s. We've got angle ZHI. Is another one of those 27s. We've got angle IZP. We'll have to go back and find it. It's kind of hard to see all of this, and Having a very difficult time right now writing where I want to be. We know that each angle was 90, and 90 minus 27 is 63 degrees. Just a second. Let's let that get out of the way. 63 degrees. So, angle IZP from I to Z to P was 63 degrees. HPI from H to P to I is that whole angle, which is 90 by definition of a rectangle. And then angle ZQI from Z to Q to I was that angle in there, which was 54 degrees. Okay? And so it's good if you'll go ahead and solve the whole picture and then answer all of those questions individually. Okay? We're going to let you work on the rhombus and the square. Let's look at number 28. Number 28, it says, how long is AC? And this is the little theorem. What we're dealing with here is a right triangle. In a right triangle, the side across from the right angle is called the hypotenuse. The other two sides are called legs. The little theorem says a segment, it says the midpoint of the hypotenuse of a right triangle is equidistant from the vertices of the triangle. The vertices of the triangle are A, D, and B. The midpoint is C. So it's saying that the midpoint is equidistant from all three vertices. Therefore, BC is equal to CD is equal to AC. And so AC is equal to 4 because of that theorem, and you can look it up and quote it. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices of the triangle. Let's look it up and write it out. Okay? Draw and label the example accurately. Again, we want you to get a ruler. We want you to measure. You're going to measure with a ruler AB. So you would set your ruler there. There's going to be a 1-inch mark, and then you've got the half, and half of a half is a fourth, and half of a fourth is an eighth. So you would measure AB at 5/8 of an inch long. We would take our protractor. We would lay the little circle there and line it up there, and we would come around until we found 90 degrees, and we'd make a dot at 90, and then we would draw up, and that gets our angle. So now we've got one side and an angle. That side is longer than it's supposed to be, so now we would lay our ruler this way, and we would measure that side 1 3/8 inches. Wherever that's at, we'd make a dot. We'd lay our protractor in there again, measure that angle at 90, get that side measured, come on in and measure that side, okay? And you can look at the odd ones in the back of the book to see kind of how to do those. Ask your instructor. for advice or ask students that know what they're doing to help you. Using the diagram and protractor to reach conclusions, again, we want you to measure precisely the angles and the segments. The conclusions, again, will be the rules in the next section. So obviously the next section is about trapezoids and isosceles trapezoids. You will discover some rules here that are the rules for the next page. So if you look at page 95, you will find the answers to the discovery problems there. We want you to measure accurately. What this is going to do again is build in your mind a mental picture of the rule that we're fixing to learn and apply. Okay?